This exam question is looking at logic gates. What logic gates are the building blocks of circuits. The idea is that we can put these gates together and create whole electronic circuits. There are many combinations of logic gates, but for AQA GCSE Computer Science there's three that you need to be aware of, and they are AND, OR, NOT. You can combine them to make NAND gates. A NOT and AND gate to make a NAND gate. You can make exclusive. You've got exclusive OR gates. You've got NOR gates. But for the purposes of the AQA exam, particularly, you just need to remember the three gates: AND, OR, or NOT. And what I've got here is a question about the OR gate. What I've got here is something called a truth table. I've got two inputs, A and B, which I need for an OR gate, and I've got my output there. Now that is called A or B, but that could easily be labelled as P or Q or any other letter. Very helpfully, this one's called A or B to remind me that I'm doing an OR gate here, but it could be labelled just P there. Okay, so what I need to do now is fill this out. So A is 0, B is 0. So if I imagine a light switch and it's two light switches controlling one bulb, with an OR gate, one of them needs to be on for the light to come on. But if neither are on, then nothing's going to happen, and that's going to be 0. So two zeros for an input. The output will always be 0. 0 and 1. Well, one of these is on now, so that's an OR gate, so it's either or. So that will be a 1 as my output. Again, similarly, this is now 1, so that means 1 is my output. These two are 1. Some students make the mistake here of putting in a 0, thinking, well, it has to be one or the other. They can't both be on, surely. That isn't true. They can both be on. So don't make that mistake. They can both be on, and the output will be 1. Okay, so that is the OR gate there. It should look something like that. Next, we've got a circuit, and we need to look at a larger truth table. As I said to you before, sometimes the outputs are labelled like this. It could be P or Q, it could be X, Y, Z, as we've got here. So what I've got is a 3 marker here, and I need to fill in 3 columns here. So I'm looking at this output, and this output. And I do them one at a time. I do them one column at a time. Okay, so A and B there are running into an AND gate. So an AND gate means that the only time that the output will be 1 is when both of these are 1. At all other times it will be 0. So that will simply be 0, 0, 0, 1 there. Okay. The only time an AND gate can output to 1 is when both the two inputs, A and B, are 1. Otherwise it's 0. Why? Y is an AND gate as well. So I've got 2 AND gates there. This question was not labelled as such. You just need to remember that this here is an AND gate, and one way to help you remember that is AN. It actually looks like a D. I think it looks like a D there. Okay, AND, AND gate. That actually looks like a D. I think it does. If that helps you to memorize it, use it. If not, then just leave it. Okay, but that, I think, that looks like a D, and that helps remember that is an AND gate. Okay, this is a NOT gate. One way to remember that is a NOT gate is there's only one input there. But what I've got here is an AND gate, and both inputs run into an AND gate, so it's the same thing. I'm looking at B and X. Okay, so B is going in there, X is going in there, and it's 0, 0, 0, 1. Okay, same thing as A and B there. Right, Z is a NOT gate. NOT gate makes everything the opposite, and there's only ever one input into it. Okay, it's like a triangle shape with a little circle on the end there, and that is a NOT gate. So if that's making everything opposite, then zeros will be 1s and 1s will be 0s, and there's my 3 marks.